about the distributive property. Okay, I want to touch base briefly on what 6.6 is about. We're not going to go over it per se, but we need to talk about rational numbers before we get into the actual distributive property. We need to talk about rational numbers. Okay, rational numbers are numbers that can be expressed as a fraction. Okay, rational numbers are numbers that can be expressed as a fraction. Basically, you've not ever seen up to this point numbers that are not rational. Okay. Anytime you have, so for example, negative 3.2. Okay. Negative 3.2. Can negative 3.2 be expressed as a fraction? Yes, it can. Okay. If you were expressing negative 3.2 as a fraction, that would be negative 3 1/5. Okay, if I was expressing it as a fraction. So negative 3.2 then is a rational number, okay, because it can be expressed as a fraction. Now, some books will say it can be expressed as a quotient, which is a division problem, okay, but a division problem we know, in other words, we know that if I have this division problem right there, that is the same thing as that right there. Okay, those two expressions are the same. So basically they're saying a quotient, I'm saying a fraction because sometimes we don't see 3 1/2 as a fraction or 3 1/5 as a division problem. But realistically 3 1/5 is a division problem. Okay, 3 1/5 as a division problem would be this. Okay, 16 divided by 5. Because 16 divided by 5 is 16 over 5, which is 3 1/5. Okay, so either way, they mean the same thing. I just use the word fraction because it's easier to tell whether or not a number can be expressed as a fraction. Okay, now, even this number, 0.3 with a negative 0.3 with the bar over it, that can be expressed as a fraction. Okay, so it's a rational number. That is a fraction, is negative 1/3. Okay, so most of the things that you have been dealing with up to this point are rational numbers. Okay, so what are irrational numbers? If there's rational numbers, there has to be irrational numbers. Okay, irrational numbers are those numbers that can't be expressed as a fraction. And you're like, well, what numbers are those? Well, an irrational number, an example of an irrational number okay, irrational numbers are numbers that cannot be expressed as a fraction. Okay, irrational numbers are those numbers that cannot be expressed as a fraction. So, an example of a irrational number would be the square root of 5. Okay, the square root of 5, if we figure the square root of 5, the square root of 5 will just keep going. Okay. See, square root of 5 just keeps going, and it doesn't repeat. Obviously, it repeats digits like the 6. The 6 is repeated through that a whole bunch, but it's not repeated in the same spot or with the same set of numbers. Okay? Now, that goes out, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 digits. Okay, and that's not the end of it. Okay, it just keeps going. And literally, we do not have enough screen time or want to figure out what that actually is. Okay, so that gets us back to then. I'll give it back to me. There we go. That gives us back to irrational numbers. Irrational numbers are, and some people will say this differently. Okay, most mathematicians that you see, and I'm not a mathematician by any stretch of the imagination, but most mathematicians or scientists that you see will call this their infinite numbers. Okay? Now, most of us normal humans would pronounce it infinite. Okay, but they do say infinite numbers. Okay, an infinite number means it just continues on and it never stops. Okay, a good example of an infinite number that you use all the time is pi. Okay, pi, our approximation of pi is 3.14. Okay, but the actual pi, and it's on the front of your book, right there, says 3.14, and it just continues on. Okay, sorry, I lost your place. Okay, but pi is an approximate of what that number stands for, but realistically, pi is an infinite number. Okay, and so those are what irrational numbers are. Now, the only thing that we're really adding to our vocabulary for today is real numbers. Okay? Real numbers are those numbers that are positive and negative, both whole numbers, decimals, and fractions. Okay? Well, up to this point, we've only been talking about integers. We said that integers were the positive and negative counting numbers and 0. Okay, well, when we talk about real numbers, you're talking about all types of numbers. Fractions, decimals, whole numbers. So you have to understand that there is negative 0.5. Okay, there is negative 1 over 2. There is negative sign in the middle, 1 over 2, and there is 1 over negative 2. Okay? All four of those numbers are exactly the same number. Okay? When you're dealing with fractions, it does not matter where the negative sign is. It still means the same number. And the reason being is 2 divided into negative 1. Okay? I have one negative sign. We learned that when we have one negative sign, the answer is going to be what? Negative when you divide. Okay? So 2 divided into negative 1 would be negative 0.5. 2 divided into 1 is 0.5, but I want to do the opposite of 0.5, negative 0.5. Negative 2 divided into 1 is 0.5. I got one negative sign, so it's negative. So it does not matter when you're dealing with fractions where the negative sign is put. Top number, bottom number, middle. Does not matter. It's still the same answer. Okay? So basically, you just need to understand that rational numbers are those numbers that can be expressed as a fraction. You need to understand that real numbers are all the numbers that you're used to dealing with. decimals means repeating decimals, terminating decimals, fractions, mixed numbers, whole numbers. Okay? Understand that integers are in the one circle of real numbers. Okay? The inner circle of real numbers. Okay? Now, we talk about that because I wanted to get to what we're doing today. What we're doing today is we're talking about the distributive property. Okay? The distributive property we have talked about before. We talked about it last year in 6th grade. We didn't stay a whole lot of time on it, but for the distributive property, to distribute something, what do we do? Like if we're going to distribute, excuse me, we're going to distribute the food items from the food drive to those people that need food. If we're going to distribute, what are we doing? Giving it out, handing it out, okay? If I distribute the test to all of y'all, I'm giving you a test, okay? I'm giving you a test that's usually the same, okay? So when we talk about the distributive property in a math sense, we talk about this. We have a problem, 3 times parentheses 4 plus 5, okay? 3 times parentheses 4 plus 5. All right, now, when we talk about this, most of the time we have been taught that we follow order of operation. We've been taught that we follow the order of operation. The order of operation says that we do parentheses, actually grouping symbols, then we do exponents, then we multiply or divide, then we add or subtract. Okay? That's what our order of operation is said. So if I follow order of operation for this problem, what would I do first? 4 plus 5. Okay? The distributive property is a property that basically gives us the right to switch it up a little bit. Okay? Because what the distributive property says is this. The distributive property says that this problem is the same as this problem. Okay? Because when we have a number next to parentheses, when we have a constant, a number next to parentheses, what does it mean that we're supposed to do? Multiply, because there's no other symbol in between them. Okay? So what the distributive property says is that these two expressions that I've written on the screen are equivalent. Okay? 3 times the parentheses 4 plus 5 and 3 times 4 plus 3 times 5 are exactly the same expression. Now, obviously, they don't look the same, so it's really an equivalent expression. Okay? Both of them are correct. If you simplify both of them, you're going to get the same answer. If we simplify the first one, this would be 3 times 9, which would be 27. If I simplify the second one, that would be 3 times 4 is 12, 3 times 5 is 15, be 27. Both of them yield 27 is the answer. Now, the reason we have to understand the distributive property is several different reasons. Okay? Several different reasons. It is probably the basis for almost everything you're going to do in math from now till the time you graduate high school and even into college. Okay? We have to understand what we're doing. And what we're doing is this. Let me do another one. We'll do a subtraction one because it applies to subtraction and addition. What you're doing is you're distributing the 6 to everything inside the parentheses. Okay? This particular example, I just have 2 things inside the parentheses. And so that is equal to 6 times 5 minus 6 times 2. Well, 6 times 5 is 30. 6 times 2 is 12. And what is 30 minus 12? 18. Now, you might say that, well, why do I need to do that? I can just take 5 minus 2 is 3. 6 times 3 is 18. Okay? That is true. The problem you're going to have is this. I want to show you. Let's see here. Is it there? Let me find it right quick here. Not there. Yes, right here. This is an example problem from 8th grade. Now, this is just in the pre-algebra class. It is not the algebra class, but the algebra class obviously has these types of problems too. You will see in this problem right here, I have 2 times negative 4h minus 13. Okay? Well, you can't put 4h, 4 times h, and 13 together. Okay, you can't do that. All right? So, to be able to simplify this problem down into our final answer, which is right here, you can understand why I'm always bugging you to write downward instead of sideways. Okay, this is one problem. Takes up the whole screen. Okay, it's got 1, 2, 3, 4, 5, 6, 7, 8 steps to get to the answer. In this, we have used the distributive property. You will see here that I have taken 2 and distributed it to both things inside the parentheses. 2 times negative 4h plus 2 times negative 13. Okay? And this is in chapter 3 of the next book. Okay? And actually, we used it in chapter 2 and 1 as well. Okay? So along with adding and subtracting negatives that we've talked about, multiplying negatives, you can look here. This is chapter 3, and all through this problem, we've got negatives everywhere. Okay, we've got multiplying negatives. We've got down here, right here, we've got adding negatives. Okay, so the things that we are learning in chapter 6 and chapter 7, when we get to it, are the basis, the foundation stones of what you're going to do from here on out. Okay? I could pull up my algebra notes from last year and you would have the same thing. Okay? So now let's go back to our notes. So, we want to know the distributive property because we want to be able to take a problem, for example, what if this was 6 times a minus 2? We didn't know that the 5 is there. We just know that it's represented by an a. Okay? Well, you can't take a minus 2. We don't know what that is. But in the same sense, this is not simplified. 6 times a minus 2 is not in simplest form. Simplest form would be to take this and distribute the 6 to both things and get 6 times a minus 6 times 2, and that gives me 6a minus 12. And that is the problem simplified in lowest terms. Now, fortunately for you, you're not going to see that until chapter 7. Okay, you thought I was going to say next year, but it may be next year, but 2015 it may be. But you will see this year in 7th grade. Okay, it'll come in chapter 7. I think it's 7.3 if I remember right. Okay, it's either 7.2 or 7.3. All right, so we got to understand the distributive property. Now, for what we're doing today, okay, here's how you're going to use the distributive property. You don't have to mess with the variables today. That'll come in another section. But here's what we're looking at. first of all, this is problem number 11. They want you to take and show the distributive property. So when they tell you to show or write an equivalent expression, okay, show the distributive property. Or the other way they express it is, they tell you to write an equivalent expression using the distributive property. Well, that's easy. You distribute it. 8 times 100 minus 8 times 4. And you're done. Do not have to simplify it. Solving means we're looking for a value of a variable. There's no variables in these. So this is just simplifying. So that's your answer. Okay, if I had this, the other thing they're going to want you to do is to reverse it. So if I had this, 6 times 5/12 minus 6 times 1/12. They're going to want you to reverse the distributive property. Okay, well, to reverse it, we look for a common factor. What's the common factor? No, 6, the one I circled in yellow. That would be the common one. Okay, 12's not a number. 1/12 is a number. 5/12 is a number. That's not the same number. The only one that has the same number is a 6. So I can express this problem then as that. And that's my answer, because they want you to write an equivalent expression using the distributive property. But I did the distributive property in reverse. Okay? So that's reversing the distributive property. Now, the next thing is this. I want you to do that problem. You have 10 seconds. Raise your hand when you have the answer. I want you to do that problem. I want you to find the answer to that problem. Salim, you were first with your hand up. What'd you get? No, I want the answer. I want one number. I want one number. Grant, what'd you get? 0.3? 23. No, not 23. Nikki. Oh, you hadn't finished it? Okay. Drew. Think it's 23. You'd be wrong. I don't care how sure you are. You're wrong. I'm pretty sure. Emma. No. You're closer. You're closer. Okay. Here's what it is. First, most of you did this step. Most of you saw that right there. What's 5/8 plus 3/8? Which is, okay, 11 times 1. The common factor here is the 11. We can take the 11 out of the parentheses, which is what we did here, and we can take inside the parentheses and add it together. Okay? Just like if we had 3 times 4 plus 5 a while ago. What did we say? 3 times 4 plus 5 is 3 times 9, which would be 27, or it is 3 times 4 plus 3 times 5. Okay? See the 3 is right there. So in our problem here, 11 times 5/8 plus 11 times 3/8, this and this, we can bring outside the parentheses. Okay? And so therefore the answer is 11 times 1, which is 11. So the distributive property is a lot easier than having to do 11 times 5/8, which is 55 over 8, plus 11 times 3/8, which is 33 over 8. Then you got to take 55 and 33 and add it together, which would be 88. 88 over 8, which is 11. Okay? Now, I want to show you, see if they've got it here. I'll try to do one that's in here, maybe not. Yeah, let's look at that one. 3 times 10.4, another way to use the distributive property. 3 times 10.4. Okay? Stop what you're doing. Put your pencils down. Don't write. I want you to do this in your head. And here's how I want you to do it. Okay? Emma, what's 3 times 10? 30. What's 3 times 0.4, Nikki? Gave you the harder one. Huh? No. Yeah, there you go. You're 1. Yeah, 1.2. Okay, Zach, what is 30 plus 1.2? There you go. You just solved 3 times 10.4. And we solved it by using the distributive property. We used the distributive property and basically said this. 3 times 10 plus 0.4. What is 10 plus 0.4? 10.4, right? Okay. Then I asked Emma for 3 times 10. I asked Nikki for 3 times 0.4. Then we told Zach to add those two together. That's the distributive property. Okay? You have actually used the distributive property since 2nd grade. You just didn't know there was a name for it. In other words, 3 times 22. Okay? 3 times 22 is 66. Okay? 3 times 20 is what? 60. What's 3 times 2? 6. 60 plus 6, 66. Distributive property. You've really used it ever since you've multiplied 2-digit numbers together. Okay? That is, huh? No. It's 486. 486. How do we use the distributive property here? Well, we do this. 42 times 10 plus 2. What is 10 plus 2? 12, right? Okay. So 42 times 10 plus 2. I was off. It's 504. If you distribute 4 times 10 plus 4 times 2, 42 times 10, 42 times 2, which is 504. Okay? Now, what you see, what you get is this. If I was to take 42 times 12, the other way. No, it's right the first time. If I was to take and multiply this out, you would get 4 and 84, right? And then I'd put a 0, and I'd have 2 and 4. Now, this okay, you've used the distributive property ever since you started multiplying. It's basically just multiplication. Because when you multiply, we multiply two things together and then we add them, right? That's the distributive property of addition. Okay? Another way to do it. Let's do this. What is 4 times 1999? Stop. Don't do it with your pencil. Do it in your head. 7996. Okay, what'd you do? Okay, hang on. 4 times 20. Okay. 4 times 20 would be 80. Then what'd you do? Right. Exactly. All he did in his head was simply this. He used the distributive property. He took 4 times $20 minus 1 cent. $20 minus 1 cent is $19.99. Then he took and multiplied 4 times that and 4 times that. 80 minus 4 cents. $79.96. Okay? So your brain functions literally in the distributive property. Okay? It uses the distributive property to solve things. You know, when I'm up here multiplying numbers in my head, all I'm doing is using the distributive property. For example, 320 times 11. Well, that's 320 times 10, which is 3,200. Then 320 times 1, which is 320, 3,520. Okay? You do it in your head using the distributive property. Okay? Distributive property is going to be important for other reasons besides that. Okay? Your homework. We're going 6.7, 2 through 21. Okay? Make sure you read the directions carefully on each problem and refer back to your notes on what type of answer they want. You may go